Midjourney is a great tool that you can use in your browser or mobile. You can give it any imagination and it will give you impressive pictures. In this lesson, we learn how Midjourney works and how it was made. This will help you use it even better. Unfortunately, we cannot exactly say what Midjourney uses behind the scene. Therefore, we can only assume, and because other tools are based on the latent diffusion model, we assume that Midjourney and other AI image generation tools uses the same technology. What we know for sure is that Stable Diffusion uses the latent diffusion model. Stable Diffusion is a free open source AI software that many applications use to generate images. So Midjourney is a Discord app to create images. The latent diffusion model is probably the underlying program, you could say, that's being used by Midjourney to produce and generate those stunning images. Midjourney may use this model and fine-tune and train them with their own parameters. Latent diffusion models are a general concept and are in the end machine learning models that perform AI generative images. The CLIP model is trained to understand images paired with natural language descriptions. The UNet model is a U-shaped encoder-decoder network architecture developed for image segmentation. In the end, these are machine learning models that are built and optimized to understand and process text that's understood by humans and models that can then generate images with that text. Latent diffusion models are based on neural networks. At its core, a neural network is like a computer program that uses many connections and layers to give an output based on input. And there are many different types of neural networks for different tasks. For pictures, we use something called convolutional neural network. And for text, we use transformer neural networks. Basically, every neural network is trained to give outputs for certain inputs. The AI image generator Stable Diffusion has a lot of technical parts, like 860 million UNet parameters and 23 convolutional layers. Plus, it has 123 million clip text encoder parameters and 12 hidden layers. But even with all this, it's not too heavy and should even work on a good gaming computer's graphic card. DALL-E 2 uses 3.5 billion parameters, a smaller number than its predecessor. This is probably and mainly because of the transition from the old diffusion model to the new latent diffusion model, which is more effective and requires a smaller number of parameters. Despite its size, DALL-E 2 generates 4x better resolution images than DALL-E 1, and it's preferred by human judges 70% of the time, both in caption matching and photorealism. While you don't need to know all the technical details to use Midjourney, it's good to know that these models are complex. They generate images using a lot of data and parameters. Neural networks take in data and give out results. They get better by checking if the results are right. One big question is, what data was used to train them? The answer is almost all the images with and without captions on the internet that's public. Midjourney and other image generation tools know a lot because they were trained with most of the internet's images. However, some parts were removed to make it safe and not create harmful content. When training, the text was turned into tokens instead of words. Each token has an ID. Tokens can be parts of words or whole words. These tokens help train the model. There is also a command in Midjourney where you can find out which tokens are important in your prompt. We will dive into this command later in this course. For training with images, the process is slightly different, but parallels the concept of tokenization in text. The convolutional neural network converts the complex spatial patterns and RGB values within images into high-dimensional vectors or embeddings. These embeddings capture the essence or semantic information of the image, much like tokens capture the semantic nuances of text. When training CLIP, both the image embeddings and text tokens are mapped into a shared embedding space. The goal here is to have images and their corresponding textual description lie close to each other in this space, just as phrase might be tokenized into several component parts to understand its meaning. An image is decomposed into a vector representation that encapsulates its content. This unified approach allows Clip to understand and relate visual and textual information seamlessly. It's important to note that real image embeddings will have many more dimensions, often thousands, and the values won't be as simplistic as the example. The analogy here simplifies the concept for illustrative purposes. While there is more technical stuff behind this for this course and using Midjourney, you just need to know about tokens. In the next lesson, we'll review what we've learned so far to reinforce and deepen our understanding. After that, we'll explore how Midjourney transforms your text into an AI-generated image. See you in the next lesson.